Hello students, we are solving the IB Math A HL past paper questions and currently we are solving the IB Math A HL May 2021 paper 1 time zone 1 past paper. And we have already solved the first 8 questions of this paper and today we'll be solving question number 9. We are solving one question each day. You will be getting the solutions to all the previous 8 questions in the playlist. The link to the playlist is given in the description area. So without any further delay, let us start with our today's session. It is containing 8 marks and it has 2 subparts A and B. So the question says, a farmer has 6 sheep pens arranged in a grid with 3 rows and 2 columns as shown in the following diagram, and 5 sheep called Amber, Brownie, Curly, Daisy and Eden are to be placed in the pens. Each pen is large enough to hold all the sheep. Amber and Brownie are known to fight. Find the number of ways of placing the sheep in the pens in each of the following cases. Part A, each pen is large enough to contain 5 sheep. Amber and Brownie must not be kept in the same pen, obviously, otherwise they will be fighting. So first of all, let me number the pens. Say maybe 1, 2, 3, 1, 2, 3, 4, 5, 6. Now, let us first of all place Amber. And I'll be taking the first letter of the names because as I have to write all the long names that they are having. So Amber A is placed in the first pen. What happens to Brownie, Curly, Daisy and Eden? Since A is placed in the first pen, Brownie cannot be placed in this first pen. Brownie is having 5 options remaining. Brownie can be placed in any of these 5 remaining pens. So it is 5 and so multiplied C, Curly. Curly is having all the 6 pens available because each pen is large enough to contain all the sheep. So Curly is having all the 6 pens. Same for Daisy and Eden. They are having all 6 pens to select from. So the total will be 5 times 6 to the power of 3. Now when A is kept in the second pen, what happens? The scenario will be exactly the same. Brownie will be having only 5 options remaining. Curly will be having 6 options. Daisy will be having 6 options. Eden will be having 6 options. So the total number of arrangements will be 5 times 6 to the power of 3. Okay. Now this will happen whenever A or Amber is placed in one of the pens. So Amber can be placed in the first pen, Amber can be placed in the second pen, in the third pen, in the fourth pen, in the fifth pen, or in the sixth pen. The arrangements will be the same. 5 times 6 to the power of 3. And these will be getting added because Amber cannot be placed in all the 6 pens together. Either Amber will be placed in the first pen or in the second pen or in the third pen or in the fourth pen or in the fifth pen or in the sixth pen. So whenever it is or, we have to add. So we have to in fact add all these. So we have to add 6 identical items. Therefore, it is 6 times 5 times 6 to the power of 3. Okay? Therefore, total number of arrangements is equal to 6 times 5 times 6 to the power of 3, which is 5 times 6 to the power of 4 ways. Now, this is a paper 1 question, so you will not be allowed to use the calculator. If you 6 to the power of 3, 6 times 6 is 36, 36 times 6 is 216. If you know it is 216, fair enough, you will be multiplying again 216 with 6. But if you think that you don't have that much of time, I would suggest that you keep your answer this way. After completing all the questions, after checking your answers, if you still have some more time remaining, then you come to this part and get the actual product. Else, if you keep it this way, 5 times 6 to the power of 4 ways, I think you will not be losing any mark, because this is a paper 1 question and you have shown how you have come to this number of ways. Okay, how you have got this answer. So this is the final answer for subpart A. Now coming to subpart B, each pen may only contain one sheet. This time they have changed the situation. Each pen can contain only one sheet. Amber and brownie must not be placed in pens which share a common boundary, else they may be found fighting across the boundary. So they cannot be kept in the same in pens sharing a common boundary. Okay, fine. First, let us analyze the situation. Okay, let us first of all place amber in this pen. When amber is placed in this pen, brownie cannot be placed in this pen because this pen is sharing a common boundary, and brownie can also not be placed in this pen. Clear? So, and this is one of the corner pens. There are 4 corner pens. So when amber is placed in this corner pen, we are seeing that brownie cannot be placed in these 2 cells, these 2 pens, and brownie is having 3 options to choose from. Okay? What happens if amber is placed in another corner pen? Maybe this one. Then also brownie cannot be kept in this one or this one. So again, brownie is having 3 options. If brownie is kept in this pen, sorry, amber is kept in this pen, you cannot take these 2, any of these 2 for brownie. I've kept amber in this pen, this pen, this pen. One is remaining, so let me take that as well. Fine, so let me take this. Amber is placed in this pen, so brownie cannot be placed in this and this. So again, we are seeing that whenever amber is getting placed in one of the corner pens, brownie is only having 3 options remaining to choose from. Okay, so we have understood this. So let us now start writing. So for amber, now let me just mark the pens. This is corner 1 pen, this is corner 2 pen, this is corner 3 pen, and this is corner 4 pen. Okay? We'll be coming to the middle pens. This is middle 1 pen, and this is middle 2. This is actually 4. Okay, fine. So Amber is placed in corner 1 pen. Brownie, Curly, Daisy, and Eden. Brownie will be having only 3 options remaining. We have seen whenever Amber is being placed in one of the corner pens, Brownie is having 3 options remaining. So Brownie is having 3 options remaining. And how many options are there for Curly? 2 pens have been occupied, one by Amber, another by Brownie. So only 4 pens are remaining. So Curly is having 4 options. Daisy, only 3 options. And Eden, only 2 options. Okay? So what is this? This is 3 times 3 is 9 and 4 times 2 is 8. So 9 times 8 is 72. Fine. And this will be the case when Amber is placed in corner 2, corner 3, corner 4. Any of these corner pens. The total number of arrangements will be equal to 72. Okay, because Brownie will be having 3 options. Then Curly, 2 pens have been occupied, so Curly will be having 4 options. 3 pens occupied, Daisy is having 3 options. 4 pens occupied, Eden is having 2 options. Okay, so we are having 4 rows, each is having total number of arrangements as 72. And Amber will be placed in either corner 1 pen or in corner 2 pen or in corner 3 pen or in corner 4 pen. Since these are connected by OR, so these will get added. 72 plus 72 plus 72 plus 72, that means 4 times 72. Okay, so total equal to 288. Okay, now coming to the middle pens. Fine. When Amber is placed in this pen, Brownie cannot be placed in this pen. Brownie cannot be placed in this pen. Brownie cannot be placed in this pen because these 3 pens are sharing common boundaries with this pen, the middle 1 pen. So now Brownie is having only 2 options remaining. When Amber is placed in middle 1 pen, Brownie is having only these 2 pens remaining. Only 2 options remain. Okay. For middle 2 pen as well, if Amber is placed in this pen, then Brownie cannot be placed in this one, and in this one. So Brownie will be having these 2 options remaining. So when Amber is placed in any of these 2 middle pens, Brownie is having only 2 options. Previously, Brownie was having 3 options, but this time Brownie is having only 2 options. Okay. Therefore, now Amber is placed in middle 1 pen. Brownie is having 2 options, Curly, Daisy, and Eden. Curly is having 4 options because 2 have been already occupied by Amber and Brownie. 4, Daisy is having 3 options, and Eden is having 2 options. Okay, so now this is what 4 times 4 is 16, 16 times 3 is 48, or 8 times 2 times 4 is 8, 8 times 3 is 24, 24 times 2 is 48. Hamper can be placed in the middle pen, M2 pen as well. The situation will be exactly the same, 4, 3, and 2. So this is 48. Total will be 2 times 48 or 48 plus 48. Equal to 96. Therefore, total number of arrangements is equal to 88 or 96. So 288 plus 96 equal to 8 plus 6 is 4. Carried 1, 9 plus 1, 10. 10 plus 8 is 18. Carried 1, 2 plus 1 is 3. 384 ways. Okay. So we have completed solving question number 9. And if you are wondering who am I'm Nilanjana Sanyal. I tutor IB Math A, SL and HL students who are kids of Indian parents or NRI parents. And I have decided to, I do take group online tuitions, but I have decided to uh, conduct group online math tutoring sessions in a slightly larger scale. But even then the groups will be quite small. And if you are interested in joining those sessions, please do contact me. If you have anyone, if you know anyone who is interested, please do share with them my contact details. You may mail me, you may text me. You are seeing my phone number or my email address given. So do contact me. Okay? And thank you for staying with me till the end. We'll be meeting again tomorrow with question number 10. Till then, bye.